Welcome, everyone, to the GSA webinar series. I'm James Corsi, GSA's Executive Director. We have a very timely and exciting session for you today with Mike Moses from Virgin Galactic. But first, a little update and a little housekeeping. To my side, you'll see a QR code. This will get you directly to our website, the GSA website. I also want to thank our title sponsor, RS&H, and our co-sponsors, BRPH and American Company. We have a total, believe it or not, of 8 new members since our last webinar. They include the Hokkaido Spaceport, All Points, Burns and McDonnell, Scientific Lightning Solutions, the City of Paso Robles, Highlands and Islands Enterprise, Puerto Rico 5G Zone, and Teachers in Space. It brings our total membership up to 66 from 53 last year, a 25% increase. I also want to talk a little bit about the summit, and I'm pleased to announce that Jim Bridenstine will be our keynote speaker at the summit on January 29. And he will be joined by Pamela Underwood from the FAA, and again, Colonel De Silva from the U.S. Space Force. We're still refining the agenda at the moment, but we will brief you in more detail at the next webinar, which is on November 14 at 1 p.m. Please, by the way, register for the summit as soon as you can. And members, you should use your code that Steve sent you, as there will be no charge for you to attend. And as you all know, GSA has its summit meeting at the beginning of what we now call Commercial Space Week, which includes a meeting from the U.S. Space Force, Space Mobility, and also, of course, SpaceCom. So please register for Commercial Space Week as well. GSA members get discounts on their registrations for both SpaceCom and Space Mobility. So do not miss out on the savings and the value of attendance at these great events. Also, given the fact that the U.S. Space Force will be on the SpaceCom show floor and the anticipated size of the attendance at SpaceCom this year being close to 4,000, it would be great for as many of you as possible to have a booth so our spaceport community would have a real presence. Please contact Steve or myself for details. Okay. When I can't sleep at night, I ponder a question. And that question is this: how can Mickey Mouse and the Disney World help spaceports? Well, to tease you with the response, here is one of our new members, Dave Acomb of AOA. Over to you, David.
Thank you, Jim. It's a real pleasure to be here. We are excited to be members of GSA. And hello, everyone. I'm a principal architect at AOA. And so certainly I want to thank GSA for giving us this chance to do a brief introduction and some of the ways that we've been involved in some truly unique projects. I'd also add it's a real privilege for me to be here today representing close to 100 employees that are amazingly diverse and exceptional in their talents, from artists, architects, designers, engineers, project managers, painters, fabricators. The list goes on. But it's an incredible team that's been assembled and has grown over time to create unique designs, unique experiences, and which has led us to, well, what was our mission statement? When people used to ask, well, what do you guys do? Well, if you boiled it down, it's we dream, we create, and we build. And that's our simple way of answering, that complex question for all that we do. What that does do is it leads us into creativity, innovation, creating strategies. And so part of answering Jim's question in today's presentation is, how has Disney impacted our company and the many projects that we do, including those of recent that are space related. And it'd be easy to say right from the beginning, it all started because two of our founders each had 20+ years as Imagineers, or that now we have on staff a lot of former Imagineers and Disney employees. But in reality, it's we paid attention to the culture, the philosophy, the fundamentals that led to the legacy of Disney having this successful brand. We use tools like storytelling and everything that we do. We have this incredible attention to detail that's necessary. We believe in authenticity in the stuff that we create. And, guests are smart. People are smart to know what looks fake and what looks real. So it takes time, it takes effort, it takes dedication to get us to that point. We pay attention to things like the guests and the end user experience. It's something that was always ingrained in what we did. Whether it's an employee, a guest at a park, a staff member, a facility manager, a janitor, whoever's involved in a project, you have to think it through. What we used to say was front of house stuff the guests would see, the back of house stuff that they don't see is just as important as the way things operate and how successful they are. You could say we're located in 2 locations right now. Our headquarters is in Winter Park, Florida. We have a branch office out on the West Coast in Burbank. We've done multiple projects, certainly within North America, but we also have projects that we've done around the world. Again, that expertise is far and wide within the company with the type of projects we've worked on and the roles that we've played. So we do know how to work internationally as well as within the United States. And what I'm showing right now is a pretty simple flow chart of how projects kind of work through our office. I mean, we're a little bit of a right brain, left brain company. One side being very, very creative and the other side being very analytical in how to get projects engineered and completed. But like a brain, there's different parts are responsible for different things, but you use both sides all the time. So what we're showing is how something starts in a very early phase. Again, it's what's the vision, what's the mission, what's the story, what are we trying to accomplish at the end? And then following it through a very specific path and how to get to an end product. What you don't see listed up here are things similar to the space industry is life safety, durability, testing, maintenance of equipment and things that are being designed. The budget is huge. The schedule is huge. How do you get, again, from that point A to point B without losing that beginning point of what was really in the design from the very beginning? What was the intent? What we do have, which has really been a strength as the company has grown, is being able to take a project from the very beginning concept all the way through to a ribbon cutting, let's say. Having people that are on staff that know how to design, know how to take it to that next level of engineering, know how to understand what's being completed, having conversations with people who have been in the construction industry for their careers to be able to look at quality control issues, look at materials that you're using, looking at the costs and how to deliver a project. What's the schedule going to be out there? All these things nowadays, it's like rolling the dice the way the industry's become, especially after the pandemic. But to get it to that final point so that it is a successful experience, it is a successful project. So as a bit of a teaser, I'm putting up out at Epcot, there's a pavilion that's called the Mission Space. And within Mission Space, the design intent was to create a guest experience of taking people 220 miles above Earth to a space station and a restaurant dining experience and how to pull that off. So what I'm showing here is that flow again of blue sky concepts of what can it be? What would the space feel like? What do we want people to see and feel? And then working that through the engineering, through architectural drawings and engineering drawings, and starting to look at how do you put this together, having conversations with vendors and all the stuff that goes into one tiny space that's audio visual, lighting effects, just the practicality of how do you pull that off. And then the actual creation of mock-ups with vendors so you can actually feel the space and test the pieces to see if it's going to have that ultimate effect that we're after. So then the install is something that we're able to do and coordinate, which is getting the stuff on site, going through all that testing, organizing the construction team, working it through, with client meetings and checking that budget. All those tests, hundreds and thousands of hours going into one specific area, and then a final product that would give you that ultimate guest experience. If you go on YouTube, there's a ton of videos of this P220 restaurant that you can check out that guests have taken themselves. Part of that destination in space was being able to show food that was going to be grown in that restaurant. So looking at the technology of what's been part of the space industry development, this whole idea started in a tiny black box, mirrored black box in the back of our office with one of our technicians, Jake Taylor, was looking at what we could do to with mirrors to make something look like it was infinite and growing, and then going from sketches into those rendered drawings again and working it through to make it look realistic, and the fact that it needed to rotate, what kind of technology do we have to have, creating food that looked realistic for there, and then again the final implementation of all of that into a final product is once you're in that restaurant space. And then the dining space itself, to design it and work through the theming of it and what it needed to feel like, to feel futuristic, feel like a space facility. Looking out windows back at the Earth, it was Industrial Magic and Light, or Light and Magic, created the movie of the Earth, and then it was the coordinating of that so that it really appeared with all the projection equipment that we had, like you were in a restaurant in outer space above the Earth to get that realistic effect. And again, that authenticity is everything. And so a teaser as to how something works through our office from that Disney approach of what does it need to be, that attention to detail, what's the guest experience, and then the final product. One of our other strengths is project management, maybe that other left side of the company, if you will. And these are just 4 images primarily to show the complexity of these projects that we were involved with Disney in a lot of different roles on the project management side and the design side and the implementation of the final works that gets us to this point. I mean, these are years in development. They're thousands of hours in creating the ultimate effect. And then how do you build it? I mean, these pictures are final products, but they all began with those creative drawings and images, and they had to go through endless hours of engineering and mock-ups and the testing and the technology now in these rides. If you've been on some of them, you appreciate it. If not, and you have that opportunity, the audio, visual, and special effects now are just so realistic to take you to another place. And all of that comes with an excessive amount of time, but also people with true expertise in how to kind of put that all together. Budget and schedule and coordination and shop drawings and vendors, all of that comes into the project management side of our office, which is being on site and help getting things done. It could start with the selection of the architects and engineers and the consultant teams, all the way through to just being on site to help coordinate and do quality control checks. Again, it's to show 4 pictures doesn't do justice to all the work that gets done to bring these things to its final conclusion. On the design architecture side, we've had incredible opportunities to take projects. In the last 3.5 years, we've been fortunate to work on amazing space-related projects, very large scale, very sophisticated. One of them with Mike's company, Virgin Galactic. And every one of these things has been unique in not only what their approach is to the commercial space industry and what they're trying to accomplish, but then there's also this amazing mission that they all have in common, which is using space as a way to take people up to be able to look back down at Earth and to be able to appreciate all that we have to do to preserve it and protect it and cherish it. So we've been able to program and do concept designs and kind of work with these clients to accomplish that mission. The Advent Health was a client that called up and said, we're tired of patient rooms looking like they have been the same way probably since World War II. And what can we do to change the guest or the patient experience? So it's taking medical office spaces and be able to create an opportunity not only through the interior design of the space, 2D graphics and paints.
David, I hate to interrupt, but we need to move forward here.
Yep, I'm almost done. I had my clock running. I was down to 2 minutes. So I'll go through, again, showing some images of highly technical, innovative space. And thanks for that heads up, James, by the way. And then showing something that relates to Michael's company, which is doing a mock-up of systems for figuring out how we could show within the mock-up how space is going to look through the eyes and the windows of their ships. And this is a 2-week process to be able to see how all that technology worked. And we were able to, again, work through it to kind of get it to that final quick mock-up design to test all these systems. So again, relying on the talents and the experience allowed us to do that very, very quickly. So I welcome everybody to come to our website. You'll learn a lot more about us and see a lot more at hand. But James, thank you for that opportunity. And like I said, we're happy to be a member and glad to be a member of GSA and look forward to working with you and creating many more opportunities. Thank you.
Thank you. Thank you very much. I'd like to introduce George Nield, who will subsequently introduce Mike Moses. George, over to you.
Hey, thanks, James. Just wanted to take a minute to share some news about 3 different activities that are coming up that GSA and our members are involved in. First, I'm excited to be serving as the co-chair of the High-Speed Aerospace Transportation Workshop, 6th edition, along with Oscar Garcia, who leads GSA's point-to-point working group. The workshop will be held in Midland, Texas on November 16th and 17th. And we'll be talking about vehicles capable of transonic, supersonic, hypersonic, and suborbital and orbital flights. And I'm expecting some very interesting discussions. Second, GSA recently agreed to partner with the Hague Institute for Global Justice to enable the near-term testing and operations of vehicles capable of performing point-to-point transportation through space. Although industry is making rapid progress in developing the technologies needed for such missions, there is currently a significant legal and policy vacuum in this area, which could negatively impact their application. So our first step is going to see if we can put together a roadmap regarding how best to address those issues. And we'll be talking more about that at the GSA Spaceport Summit on January the 29th in Orlando. Finally, GSA has agreed to co-sponsor a workshop on the development of a human research program for civilians in space that will be held at Oklahoma State University on January 23rd through the 24th. NASA has lots of data on how spaceflight affects its astronauts, but many of the people who are going to be living in, working in, and visiting space in the future are likely to be much older, much less fit, and have much more complicated medical histories than NASA astronauts. So the goal of this effort is to begin to outline a research program that would help us understand what kind of preparation, training, countermeasures, medications, or other treatments would allow us to have as many people as possible to fly to space in a safer and more enjoyable way. So at this point, I'm excited to be able to introduce keynote speaker, Mike Moses, who's president of Virgin Galactic. Mike oversees the commercial suborbital spaceflight program for Virgin Galactic. He leads the team in all aspects of safety, mission operations, and FAA regulatory compliance. He came to Virgin Galactic following a distinguished career with NASA. From 2008 through July 2011, he served at the Kennedy Space Center in Florida as the launch integration manager, where he led all space shuttle processing activities from landing through launch. Mike also chaired the mission management team, where he provided ultimate shuttle launch decision authority. Other NASA experience included working as a flight director at the Johnson Space Center, where he led teams of flight controllers in the planning, training, and execution of space shuttle missions. Before being selected as a flight director in 2005, Mike had more than 10 years of experience as a flight controller in the Shuttle Propulsion and Electrical Systems Group. Mike attended Purdue University, earning a bachelor's degree in physics and a master's degree in aerospace engineering. He also earned a master's degree in space sciences from Florida Institute of Technology. He's a two-time recipient of NASA's Outstanding Leadership Medal, as well as other NASA commendations and awards. So Mike, thank you so much for being here today. We're very excited to hear from you. Over to you.
All right, thanks, George. I appreciate the introduction, and it's nice to see you again. I should say, David, thanks. I didn't realize you were speaking today. I can endorse the work that AOA does. They've been doing fantastic stuff with us here at Virgin Galactic. It's been truly amazing to see their capabilities. So glad to see and proud to see you're part of the Global Spaceport Alliance. That's a nice add. And then definitely a shout out to our friends at Spaceport America who are on the phone today, and other spaceports around the country and around the world. So thanks for the opportunity to talk today. I'm going to share my screen here while I'm going on the introductions. And we'll get to full screen here in a second. There we go. So as George said, I've had a background mostly at NASA, working on the space shuttle program, fortunate to work in Houston in mission control, and eventually leading those teams, but then moved down to Florida at the Kennedy Space Center. So I was there kind of as Kennedy was starting the move from a commercial or a government spaceport into a commercial spaceport, and the transformation that happened out on the 45th at the range under General Monteith. I was there for the first SpaceX Falcon 9 cargo launch to space station. And then I left to join the commercial space industry myself, to come here to Virgin Galactic. Started off in our development and test facilities out in Mojave, working with our contractors, Scaled Composites, and Burt Rutan's team, who had built the original prototypes, doing our tests there. The Mojave Air and Spaceport and the Edwards Air Force Complex is a fantastic place, kind of a cradle of aerospace innovation. And so the folks at Mojave Air and Spaceport were fantastic supporters of everything we needed to do to get our program off the ground, literally. And then we moved down here to Spaceport America, to our operational headquarters in New Mexico, and proud to lead the team through the test and commercial operations we're doing here. So for today, I was going to keep us focused on spaceports, given the audience I'm speaking to. So I'll do a little recap of what we've been up to here at Virgin Galactic in the last 6 months. I'll focus a little bit on spaceports, kind of blending back and forth between what we do here at Spaceport America and what we will do in the future, because that's kind of where I wanted to wrap up with, is the future of Virgin Galactic is the future of spaceports. Our goal is to have multiple spaceports around the world that are operating our vehicles on a regular routine basis, opening up access to space in a safe and successful manner for everyone to deliver very transformational customer experiences. So with that, let me go ahead and switch. So just a quick set of background, right? I'm sure most people are familiar with Virgin Galactic and our systems. We are an air-launched vehicle, so we have two parts, a mothership and a spaceship. The spaceship is carried by the mothership as a first stage. We take off as a mated pair. We climb up to about 50,000 feet, and we release where we light the rocket motor and accelerate through the speed of sound, going Mach 3, 3.5 times the force of gravity as you rocket into space. The motor cuts off, and we are suborbital, not an orbital platform. So gravity will win very quickly and pull you back down, but you get a good 4 minutes outside of the atmosphere in space. When the motor cuts off, you are weightless inside the cabin. You're free to float around and unstrap. You see the amazing view of the Earth below you. Out to the side, you see the limb of the Earth, the thin band of the atmosphere, and the dark black sky of space around you. And you get a chance to experience that view. So you get to ride the rocket to get there. You get the Zen-like experience once you're in space out of your seat. Strap back in, turn around, come back and land. And we land back at the runway we took off from. Grand total from takeoff to landing is about 1 hour and 15 minutes. We round that and kind of call that about 1.5 hour journey for our vehicle. So we are, and I'm sorry, this slide was supposed to be up while I was talking about that. So we have kind of 4 stages to our system, right? We take off as a mothership spaceship pair. We have a hybrid rocket motor that gets us to space. We use a feather technology for reentry, which I'll explain in just a second. And then we land back on our runway. So that flight profile is pretty straightforward, and we kind of break it down to those 4 phases. And our goal is to focus on the simple and safe method to use in each of those 4 phases. So on the ends, takeoff and landing, we're very airplane-like, and we're using very standardized airplane equipment and systems. On landing, we're an unpowered glider, so there is that challenge, right? But from the standpoint of basic systems, basic reliabilities, and basic operations, we're airplane-like in those phases. The other 2 phases are the space side, the boost and the reentry. For boost, we use that simple hybrid rocket motor. It's a combination of a liquid oxidizer and a solid propellant, very simple valve and plumbing systems. They're safe and storable on the ground, so there are no real hazards in the ground operations. And in flight, you can shut it down anytime you want. And that's our system. Our abort modes are basically stop the burn, come right back home. And so that's a really nice, safe and simple, reliable commercial boost system for us. On the entry side, we use what we call the feather, where we raise the tail of the ship. And this lets us kind of convert our aircraft or spacecraft from one with wings, like a space shuttle glider re-entering, to one that's more like a capsule, a Dragon or an Apollo capsule coming back into Earth. And so we get the benefits of both. So when we want to re-enter the atmosphere, we're quite literally kind of doing a belly flop back in. We aero brake very fast while we're very high. So the structural loads on the vehicle are low. The thermal effects are spread across the belly, not taken on the nose and the leading edge. So we get to dissipate the heat very quickly. And we re-enter fast, so we don't give that heat time to soak into the airframe and the structures underneath. So it's a really great, simple, reliable re-entry system for us. And then again, landing like an airplane back on the ground. So in the last 6 months, we've been busy. We have launched commercial service, as we said we would do here at the beginning or at the middle of this year. So we wrapped up our test program. This was our last test flight out of Spaceport America back on May 25th. The Unity 25 flight, we flew 4 employees in the back as our final proof and verification of the onboard experience and the ground training program that we use for those customers. We turned around a month later and flew our first commercial flight, Galactic 1, with the Italian Air Force. This was a dedicated research flight that the Italian Air Force had contracted along with the Center of National Research in Italy. And a fantastic demonstration of it's not just people going and looking out the window. There's really great science you can do on a suborbital flight. You get a good 3.5 to 4 minutes of solid microgravity time frame and a nice gentle takeoff and landing phase on both ends of it. So it's a really great microgravity research platform as well. And we're so proud of the partnership with the Italian Air Force to help launch that service for us. A month later, we flew Galactic 2. And I'm missing a picture. Sorry, that didn't come through in the PDF conversion. But Galactic 2 was our first flight with private astronauts on board. And this was a great demonstration of folks who probably don't normally think they'll get a chance to go to space. So we had a few folks who won their tickets in a lottery that was sponsored, and they got to go, as well as someone who had a medical issue that probably would have disqualified him from a normal idea of a commercial space flight. And it's easy for us to kind of accommodate folks of all walks of life and all backgrounds. And our goal is to try to open up access for everyone. So another great demonstration there. A month later, Galactic 3 with some of our founder astronauts. These are some of the most fantastic people in the world that signed up with us back when we launched our program and have been on board with us for 15 plus years in some cases. So a great chance to get to fly these 3 individuals on Galactic 3. And then just a few weeks ago, we flew Galactic 5 at the beginning of October, another group of founder astronauts on board. Yesterday, we announced Galactic 5, which will be launching on November 2nd. So in just about a little over 2 weeks, that'll be another research flight with a few researchers on board, Kelly Girardi and Alan Stern, as well as one of our private astronauts from the founder group joining them as well. And then we're going to, just keep clocking that away. So 5 flights in 5 months for us in commercial service, fantastic track record. We're really proud of the team and the vehicles. But what does all this mean, right? So I think what it means, is we've been demonstrating that we have what we need, right? Our vehicles are performing superbly, right? They're behaving themselves. Everything's going well. The flights repeat themselves very reliably. We're able to turn Unity on a monthly basis. Now, Unity is our first vehicle, right? And by being our original test vehicle, it's therefore a little heavier. So we're limited to 4 people in the back. So we're not carrying the full complement of 6, but we're able to demonstrate the techniques and the processes and the methods we need to use. And it's a really good proving ground for the future, so that while Unity maybe only turns once a month, we're learning the lessons we need to be able to increase that cadence in future space vehicles. But more importantly, and probably best of all, we're demonstrating that the experience is, pardon the pun, out of this world, right? It is a breathtaking, transformational experience. The stories we hear when folks come back, the testimonials they're given, the reactions from their family, it is amazing. It's the reason Richard Branson had the dream years ago. It's the reason I left NASA to come work for Virgin Galactic. And it's just an amazing experience to get to be part of delivering that to our customers every single month down here. So that's kind of what we've been up to. So, basically hugely successful. But if you looked at the stock market or you talk to our CFO, he might not have the same outlook that I do and say, what the heck's going on in that world? And it's pretty simple. I'll boil it down to one simple thing. A single spaceship is not a fleet. It is an expensive thing to develop. It's an expensive thing to fly, and you don't get scalability out of a single vehicle. So for that, we are building our Delta fleet of spaceships, right? We need to have vehicles that are cheaper and faster to build. They need to be easier maintained and able to turn quicker from a maintenance cycle. All of that fields a fleet that's able to operate at an extremely high rate, eventually leading us to daily operations. So going from what we know today of monthly flights to daily flights in a several-year transformation as we bring that Delta fleet online. Our designs are underway. The teams are busy working on all that. Tooling is getting built and about to be delivered. Our construction facility in Phoenix is going to come online in the spring, and we're going to start assembling ships. In 2025, they'll start flight testing, and they'll move into commercial service in 2026. And so then we have what we've been looking for, which is a full spaceport. More than 3 spaceships, but again, multiple spaceships, multiple motherships, flying 1 to 2 times a day. We set a target for ourselves of 400 flights a year, just to kind of round up and say that's daily flights plus some extra. And that's where we're headed. Now, all of this requires more, right? We need more spaceships. We need more motherships. We clearly need more facilities to house those vehicles. And we need places for the customers to tie back to what David was talking about with AOA. We've been getting their help on what we would do with our customer training and hosting facilities, and how do we help with the immersion of the folks that are going to be going to space with us. And then once this is full, we need more spaceports, right? Where do we go next? And then at that point, we truly are a space line for Earth. So that's where we've been and what we're doing. I'm going to now switch a little bit and let's just talk about spaceports. And I got to highlight our amazing facility here at Spaceport America, just outside of Truth or Consequences in Sierra County, New Mexico. An amazing facility, and the state of New Mexico and the New Mexico Spaceport Authority have really put together a fantastic facility, and we're proud to be one of the anchor tenants, the anchor tenant here. So what do we have in our system? So as we talked about, right, we're a horizontal launch vehicle. So I need a runway, a very long runway that's pretty wide with lots of good gentle turns off the taxiways, and everything you need to operate. As you can see, right, our mothership is a unique aircraft, pretty wide body, about as wide as a 757. And so taxiing on the ground is a little bit of a challenge. And when you line up on final, you better not be on the center line because you're over there flying in the right-hand fuselage. You need to be offset a little bit when you're coming in for landing. But we have basically runways and hangars that we need here at the building at Spaceport. It's an important distinction for those of you in spaceports. You're also an airport, and there's a lot of regulatory factors that play as to which parts of the facility are designated as spaceport and which part are designated as airport. Whether you're a private or a public airport, all of that stuff kind of factors in. I just wanted to highlight some of those nuances, right, that are at play as it relates to future spaceports or other spaceports around the country or around the world. So in addition to a runway, we need a hangar. We have a truly iconic facility here at Spaceport America called the Gateway to Space. It is kind of a combination terminal hangar facility. So it houses both our vehicles and our staff, as well as our customers and the departure lounge. A fantastic piece of architecture, a beautiful design, blends into the landscape, a truly amazing place if you haven't had a chance to visit. As you look to scale up, I don't think this is a scalable operation, right? Every single hangar doesn't need the customers in it. You do need the heavy maintenance bays. You need places with heavy environmental control where you can do other activities, places for hazardous operations. But as the centerpiece of our start location, the Gateway to Space is truly an amazing, amazing facility for us. We also need commodities and telemetry, right? So we have Jet A, avgas that we need. The Spaceport Authority here provides those for us. We have our own facilities for our pressurants and propellants, so helium, nitrogen, nitrous oxide, and the like. We have that at a facility here ourselves. For telemetry and tracking, we have the infrastructure related to our radios and communications to the vehicles. Obviously, the RF management with the surrounding airfields and air bases around us have to be managed. And here we use the White Sands Missile Range for that activity to manage RF. But that's an important thing. We don't actually require ground-based tracking. Our antennas track them ourselves a little bit just to keep locked on, but no C-band or our radar type tracking required on our vehicles for what we do in this suborbital profile. The other most important part for us is the airspace itself. And I apologize, there's a lot of detail packed in here, but on the sectional on the right, and kind of removing some of the background you can see on the left, we operate in the 5111 restricted airspace associated with the White Sands Missile Range. Spaceport America is basically right in the heart of the 5111 restricted airspace around us. Just over the mountain range at Holloman in 5109, there's a much bigger restricted airspace, but we operate over here on the west side of that mountain range. But we need a bigger area than that to climb. And you can see on the right, we kind of highlight those red arrows are what a typical launch track would be for our mothership. So we fly out into the NAS, the National Airspace, depart the restricted airspace, and we have a series of ADCAs, air traffic controlled assigned airspace that we use with Albuquerque Center, and they basically allow us to transition. Now we're up at 40,000 feet by the time we're exiting restricted airspace, so we're already well above commercial air traffic at that point. But we do have an ATCA set up, and then you can see a little cutout on the left. There is also a TFR, a temporary flight restriction, that's in play for our spaceship solo part of the mission. But that's basically a big integration part. It requires us, it requires Spaceport America, the Department of Defense over at the Missile Range, and the FAA Air Traffic Control Centers to kind of be in coordination. Lots of good letters of agreement, memorandums of understanding, and how we operate and control our flights around this airspace. So I just wanted to highlight the airspace is a big thing. Now, I'm not showing the Edwards Air Force Space out at 2508 in the west, where we operated out of Mojave. Again, that's a really great airspace, but it's a multi-user facility and really fantastic for testing, gives you a lot of flexibility. But there are a lot of other users, and us trying to fly spaceships daily out of there would not probably be a commercially sustainable business. One of the reasons we are not operating commercially out of the Mojave Spaceport because of the 2508 region. There is some other things that occur, right? So because it's the missile range, there's a lot of other defense, national security uses. And on both good and bad, there's a giant GPS jamming facility a little to the north. And so there might not be anybody in the air, but if the GPS jamming is in test, that can also cause us to have some schedule restrictions at play. Obviously, the weather is an important thing to keep in mind when you're operating. We have obviously limits. Mostly for us, it's wind and rain that we're looking at, but temperature extremes are at play. But the good news is the weather in New Mexico is always perfect. There's never any bad weather at all. There's never any snow. There's never any flooding. Oh, wait, these pictures kind of disprove my theory there. We do get occasional extreme weather here at Spaceport. There are no snow plows at our facility, and we do get sucked in every once in a while with a nice winter storm. So we don't have flying weather every single day of the year, which is why we want to be able to look at being able to fly multiple times a day when we get a weather period that hurts us. So we obviously need customer facilities. So here's a couple inside pictures of the customer facilities within the gateway to space. We have lounge and training areas, meeting spaces, places for them to gather. There's a lot more than this that's not shown. We have our mission control located here as well. Mission controls around the world tend to look like computer showrooms. So, right, this would be a Dell showroom, lots of displays and lots of TVs, but it's the people that sit in those chairs and the data on the screens that make it a mission control room. And we're no different than most control rooms around the world. We do have remote control room capability for our other engineering and design centers that we have across the United States, and they can tie into our missions. There is security, fire, rescue, medical, search and rescue capability, medevac, both air and ground. Those are all needed for an operation that's carrying humans on board. We need support for our staff. There is no place to go run out and grab lunch or get something if you forgot it. So having transportation and food, plus shipping and receiving and deliveries to the site are important. So that's a factor we got to consider. And then the community. I don't want to miss the community side. The support we get from the local states, local governments, and the local communities in Las Cruces and Truth or Consequences, as well as the rest of the state of New Mexico, is absolutely amazing. So that's kind of an overview of what we use and how the services are set up here at Spaceport America for Virgin Galactic. Obviously, could talk a lot more in depth about any one of those topics and the pros and cons. But I wanted to use this as an opportunity to just highlight for all of you in the Spaceport Alliance some of the factors you want to think about as you set up services, set up facilities, look to the types of customers you attract, right? Horizontal launch needs a slightly different thing than vertical launch. But it's really not too hard to accommodate. And most of the infrastructure you'd probably put in place at a vertical launch facility, the horizontal launch capabilities are going to help service logistics anyway. So it's a really great combination to have here at Spaceport, those two facilities in one. So what makes it great? And here I'm not going to talk specifically about New Mexico and Spaceport America, but spaceports in general, right? What makes spaceports great? Really fantastic state and local support, right? An iconic facility that kind of is a showpiece of what you're doing, because at the end of the day, these are consumer customer businesses, right? And we want to be commercial with our goals. Having a postcard landscape fits with that, right? You want to be iconic with where you're going. Obviously, great flying weather and fantastic airspace with very little traffic and easy scheduling. That's what makes great spaceports. What makes it hard, right? You're usually sharing that airspace with national security users. I use the example of GPS jamming. Even if no one's flying, we might not be able to fly that day due to other activities on a test range. By definition, spaceports tend to be in remote locations. They don't always necessarily have a lot of great third-party services located nearby. You might have to be bringing in a long logistics chain or helping develop facilities and services that you need locally to your area. Having a stable state and local commitment and funding is really key. And having long-term commitments to that is really important. Fluctuations there can really kind of wreak havoc in a business plan. And so that's an important thing. And so if that fluctuates a lot, that kind of makes it hard to set up a long-term stable business. And obviously workforce, both access to an existing workforce, as well as the parts that need to be there for the families of the workforce. What's the community like? What other job opportunities are there for families? What other businesses similar that you can draw on? And so these are kind of pros and cons to any spaceport. I'm not talking specifically Spaceport America here, but that's kind of just a highlight of what makes spaceports great and sometimes what makes it hard. So now let's talk about future, and this is back to the future of Virgin Galactic, right? We're going to fill up this spaceport here at Spaceport America within a couple of years after getting our Delta fleet online. Daily flight operations is what I call a full spaceport. Now, we could fly more than once a day, and we'll have the capability to do that. But just to kind of draw a marker, flying once a day is what I would call a full spaceport, right? Now, we obviously can be flying more than that, but just for, let's be a little reasonable for a second, and we'll just say, let's aim for daily flights. So that's a full spaceport. Then I need another spaceport and another and another. So where's our future? So as we look to future spaceports, these are some really important considerations that we want to factor in, right? Airspace and access, clearly. Having restricted airspace is really important, but by making it restricted, your access to it becomes extremely limited. Our system can go operate off in the NAS, in the national airspace, right? We can operate in that regime. It's a lot simpler to schedule in a restricted airspace, but there are other users who usually have higher priority than you. So there's a trade there to the airspace access you have. Schedule assurance is kind of a really big deal as you look to commercially expand spaceports around the world. Weather is another important, obviously, but the key here is not only the weather itself, but the accuracy of a forecast. That's really the key. You need to commit to fly to space usually earlier than you need to commit to take off a commercial airliner. So having a good forecast and being able to commit to good launch weather before you get there is really important. And so the accuracy of a forecast is key. Population footprint, the calculation is, I'm sure most of you are familiar, it's called E sub C, an expected casualty footprint, right? There's a debris hazard area that goes along with the space launch. And so for us, our system kind of stays local to the spaceport, and the debris footprints are all locally combined around the spaceport itself. So while you need a spaceport facility, having huge population densities right near the airfield and the launch facilities actually start to mess up your hazard calculations, right? So you need footprint around your spaceport, so you have great facilities, great places for your teams to live and work, but the footprint around the area you're flying in needs to be factored in as you go forward. Obviously, customer facilities and services, a company doesn't want to bring in everything themselves, right? So what other companies are around and services available? And then obviously, great appeal to the local workforce, both for them and their families. Really important considerations as you look at future spaceport sites around the world. So there's a fire hose version of me flying through a little bit of recap of what we've been up to and what we consider as we go forward. So George, with that, I think probably the more important thing is folks want to get to some questions. So I will stop sharing and
Excellent.
we can have a
Thank
chat.
you very much. That was a super overview presentation. Very, very interesting. So we've got a few questions already, but if you have others, please type them in the chat box and we'll see how many we can get to. Let me start up with a few. Can you talk about what kinds of training your customers receive prior to their flight?
Yeah, that's a great question. So we basically have folks come down 3 to 4 days before their flight, and it's a combination of, there's like mandatory required training for the safety systems, how your restraint systems work, how the emergency systems work, how your communication systems work, right? Those are required elements that we want to practice and train and get people very comfortable with. And then there's a lot of experiential things. What are you going to see out the window? What are you going to feel? How does gravity feel, both high G during boost, low G while you're in space, and then high G on reentry again? Some of these people have never experienced that. They might have had a chance to do it in a zero G aircraft or in a centrifuge, right? But some haven't had that experience at all. So having a chance to kind of familiarize yourself with what you're doing. Another big factor is your friends and family, right? They might not know much about what you're doing. You might have bought your ticket years ago. You may or may not have told your spouse you bought that ticket, but they're going to come watch the flight with you. So how do we get them through and get them familiar as well? So the training has to kind of cover all of those aspects of how we do things. And so we have a 3-day program where we kind of walk through day by day, and you can kind of break it down to what's the effects on you, what are the hardware and systems that you're going to be using, and then what are you going to be seeing and experiencing. And then we try to culminate that with a full dress rehearsal the day before flight, go home and get a good night's rest, and then come back bright-eyed and ready to go fly to space on day 4.
Excellent. We had a question from someone wanting to know if you could say a little bit about your ongoing relationships and communications with NASA.
Yeah, so we have great partnerships with NASA in a current program called Flight Opportunities. So they provide research payloads to be able to fly to space, and that program is expanding to actually be able to provide researchers to go fly with their payloads as well. And so other than the Italian Air Force mission, every other space flight we've taken before we moved into commercial service was fully outfitted with a batch of payloads being sponsored by the NASA Flight Opportunities program. So NASA helps get the researchers. They contract out with launch companies like Virgin Galactic to fly those payloads to space. So really great relationship with NASA on that front as it relates to flight opportunities for payloads. Eventually, that program's expanding. They want to use government customers to be able to fly, not just government payloads. And so a chance to fly through what's called the Sub-C program, a chance for NASA researchers and government astronauts to be able to fly on our suborbital vehicle as well.
Okay, great, thanks. So you've been at Virgin Galactic for more than 12 years now, after having spent 13 years working for NASA on the shuttle program. How would you compare the two organizations?
Yeah, so I was at NASA for a very long time. It was close to 18 years, actually. And I think it's interesting. NASA is a big organization, right? So the shuttle program was a very focused operational mindset program, very clearly set down with a series of requirements, a series of operations, pretty well-established processes, and very focused on mission execution. And so really strong similarities, and tried to bring a lot of those lessons learned over here to Virgin Galactic to keep that same focus on mission execution and mission operations, right? NASA is a giant government organization. There's a lot of bureaucracy and other things that go with it. So we try to cherry pick the stuff that really works well and maybe not try to bring too much of the other stuff that is the bureaucracy. But then you have on the flip side, right, the small business where everything is having to be criticized and examined under a microscope for cost and schedule and time, right? So how do you blend those two things together? And really great balance. So I tried to, me and along with some other people that we brought over from the NASA side and the commercial aviation side, trying to make a good balance for a commercial system. How do you get the rigor and the importance and the depth, right, that you would do in a giant government program with the speed and agility of a commercial operation? And we've done our best here to try to blend those two together.
Okay, so we know NASA, the military, and the FAA all mark space as 50 miles. Others in the international community especially look at 100 kilometers. We had a question about whether there are plans to expand the envelope a little bit to go above the Kármán line in the future. Yeah,
so again, Unity is flying right now as our test vehicle, right? It was built to be a commercial vehicle. We outfitted it for what we needed for commercial testing, right? So it's a little heavier, a little bulkier than the future Delta vehicles will be. But so that's why it carries the 4 passengers, right? So we've got extra equipment on there, extra hardware on there, because that was our flight test vehicle, right? So we're able to retrofit it and move it into commercial service. But so the altitude matters, but it also doesn't matter. If I showed you a picture of the view at 80 kilometers and 100 kilometers, you wouldn't be able to tell the difference. You're talking about 5 to 10 seconds of microgravity time difference between the two. So while it's important, it's a milestone, it's a thing, it also isn't actually too operationally relevant. So we're working through what we need to do. We're focused on the customer experience more than a number, right? We want to deliver really solid experiences, really great views, and really fantastic training to our customers.
Excellent. So you talked a little bit about the desire eventually to have multiple spaceports. Anything you can share in terms of the thinking or tentative plans or discussions about the potential for spaceports, or at least operations in other countries?
Yeah, so I think there's a couple factors to consider, right? So clearly there's like what's desired, right? And where people want to go. The view you get about 1,000 miles in any direction up at the apogee of our vehicles. So the view you'd have is kind of important, where you launch from. And I think if I had to kind of sum it up, right, we're trying to make sure our experience is blended. So as you saw some of the pictures from the folks earlier talking about where our campus is going to be. So our spaceport is in a gorgeous part of the world down here in New Mexico. Our customer training facility is going to be built just outside the fence nearby with iconic views of the desert Southwest. And we want to kind of reflect those two things. You're going to space to kind of look back down on Earth. So you want to tie those two things together. So locations are really important. And so where you can see around the world is going to be a big driver for us. So the experience you have on the ground and the view you get once you fly is a huge factor into where we go next and where we would look around the world. But with that comes the complications of ITAR and regulatory compliance and other things, export control, the things you have to kind of deal with. So naturally, there's some areas that are a little easier to move into than others. There's ones that have established procedures. The FAA partnerships are really important. And George, you know this well from the work you guys did at AST, at the FAA Commercial Spaceflight Office, right? Helping promote that industry growth around the world, and really great international and regulatory alliances to help let regulations kind of move and flow freely around. So those are all really important factors as you look where you would go next. The view obviously is a pretty big deal, what you would be able to see out the window. And so we've had agreements with folks over the years, some stronger than others, some have gone strong and then won back. But there's, you kind of think about it, where would you want to go see next around the world or around the United States? There's a lot of options in front of us. We're focused here on our first vehicles of making sure we demonstrate the operational footprint we need at a spaceport, and then we can look at how we duplicate that worldwide.
Excellent. Got a couple questions related to the workforce. Where are we going to get the workforce we need for spaceports and for operators? Relationships with schools, and anything we can do to ensure that we've got a good, diverse pipeline put in place. Any comments on that?
Yeah, that's a huge challenge, right? The workforce you have and the inspiration you're given to the future. So the focus on where workforces are and how they evolve at a commercial sense is really, really important. And it's kind of the build it and they will come, right? So the more we do this, the more we'll inspire people. So the more people we'll have in the workforce, but you do have to take those first steps. And so it kind of factors into where we go. Mojave for us in California was a fantastic test facility because it let us rapidly prototype and test quickly and develop. And it's right near an aerospace design and inventive center, right, where it's really fantastic. But access routinely for commercial operations was a challenge in the Edwards complex. And that's why Spaceport America kind of formed the way they did, was a chance to attract people outside of that industry complex for fantastic views of the desert Southwest. So the same kind of thing. Now, the aerospace industry workforce isn't as strong in southern New Mexico as it is in southern California. So help grow and transform those workforces. The next spaceport might be aimed where there's already existing workforce. It might be another area where you need to develop it all. So all that comes into play. But I mean, not to sound too fantastical for a second, but if you think about that, it's the build it and they will come mentality. Do this here, replicate it, do it again, other companies joining, doing it more. And pretty soon you have an architecture and an infrastructure of spaceport alliances and support networks that help kind of feed each other around the world. So it's a great vision for the future. Excellent. Obviously, a Spaceship Two is designed to fly to the edge of space and then come back and do that repeatedly. There's a lot of interest these days about long distance, high speed transportation, basically point to point. Is that something that's still in Virgin's plan for other systems or at some point in time? Yeah, definitely. Point to point is a very natural evolution, especially of a suborbital system. You're putting in almost all of the energy you need to do a point to point mission just to go up on a suborbital up and down trajectory. So we're learning those lessons not only with our hardware and our systems and our infrastructure, but our relationships and our regulations and our industry partnerships. And so we view this as a good stepping stone. We're staying pretty hyper focused right now on the suborbital platform. We need to get it launched. We need to get their commercial services now started. We need to keep expanding it. We need a fleet. We need to move around the world with that. But yes, the system evolves, right? So this vehicle doesn't fly point to point, but this concept moves naturally into point to point type transportation, or even into orbital transportation. The energy levels involved orbitally are obviously another magnitude for us. But between suborbital and point to point, there's really great partnerships and marriage. We're staying pretty focused right now, but there's definitely an element of our future expansion that ties to the point to point type transportation. Excellent. So we're running out of time, but one final question. I'd be interested in how you would assess the current state of the commercial space industry today, and where do you see us being in 10 years, say? Yeah, I think, it's you and I and others on this call have probably been around in this industry for a while, and we've seen where there were you saw the horizon opening up, and then things kind of slowed down, and then it opened up again, and then it kind of slowed down. I do think we're back at that dawn of the last 2 years has really been a really fantastic growth period with commercial space. It is still pretty infant, right? There are 3 companies currently carrying people to space commercially with SpaceX and Blue Origin and us. That's going to change rapidly, right? But we're at that inflection point as it starts to move. So now you can kind of go back to the visions. I think, I've heard you talk long ago, and when I joined Virgin Galactic that I bought into, right? Those are now even closer closer in front of us and really much more in our grasp. You can see companies doing great things, more companies coming to the table. So I do think we're at a period of really fantastic growth of what comes next. And we're going to see a big upswing. The commercial side of things really is starting to drive a lot of what industry does as we look to government agencies to start to contract out services, right? As you do you see the commercial crew program with the space station. Commercial cargo was a great pathfinder for it. I think we're going to see that just continue to snowball. See a lot more entrance into the field and a lot more different types of capabilities. Obviously, then you need the expansion in spaceport facilities and industry growth. You need the regulations to catch up and keep up. All of that has to kind of grow with the ecosystem, but we're on that cusp, and it is exploding out of the gate. To use a bad metaphor, exploding doesn't usually work well with rockets, but we're in a really great growth period, I think, for the commercial space industry. That is exciting. Mike, thank you so much for your talk today. This was fantastic. Really great to hear you and your discussions about what you're doing and what you see for the future. So thanks, George. Appreciate the time today. Being on today, and let me just turn it back over to James to wrap things up.
Well, Mike, that was super. Thank you. Thank you. No other words to describe it. We're at the top of the hour. So what I just wanted to do is remind you to register for the summit for SpaceCom and for space mobility for members using their discounts. Okay. Our next webinar is on November 14 at 1 o'clock Eastern, and will be a discussion on the new era of architecture. We're putting a panel together on that. And for now, take care, and the meeting is over. Thank you all very much.